Hello, Algebra 2 students. Let's get going with Unit 2 notes, Day 1. Here you're going to want to write the word quotient. Here, y. There, x. Here, that's a triangle and then a y next to it, and then a triangle with an x to it. That stands for change in y over change in x. And here we have rise over run. These are all the different ways that we can find the slope of a line. And I'll be sure and go over them as they present themselves during the lesson. Concept, classifying the lines of a slope. This slope is rising from left to right. If you'll notice, the very right arrow is trending up. Therefore, this has to be a positive slope rather than spell out positive. Let's just say this is a positive slope. This one is trending downward from left to right. Notice that very right arrow is trending downwards. This is a negative slope. This one here, that horizontal line, that's going to be a 0 slope. And then this line right, where is it? No, here, this line right there. It's vertical, up and down. That is a undefined slope. And here they want you to write the equations of the given lines. Well, we have just gone over the fact that, well, if this is vertical, then it's undefined. But in order to write the equation, this little word right here might help you. Flux. V stands for vertical. U, that stands for the fact that the slope is going to be undefined. And X tells you how to begin your equation. So the equation of this line is X equals, and then just take note of where it's going through the X-axis. That is really small. Give me a second. I'm going to have to move this closer to my face. Okay. It looks like it's going through the X-axis, where X is -3. Now, boy, H stands for horizontal. 0 stands for 0 slope. And Y says, if we have to write the equation of the line, start with Y. And this one looks like it's going through where Y is +2. Looks like it's crossing the y-axis at +2. So your equation for that line is y equals 2. Find or calculate the slope, classify the line. We're going to find the slope and it gives you a picture of the graph. Take a note of whether or not the slope or the line is positive or negative. If the slope is positive or negative, this is trending downward from left to right. This will probably save you the possibility of getting it right or wrong. It's trending downward from left to right. That right arrow is pointing down. So we know that our slope is going to be negative. Then what I would do is I would try to find a perfect coordinate on the graph. It looks like that right there is a perfect coordinate. Looks like it's the coordinate -2, 2. Let's find another one. Looks like that is a perfect coordinate. Looks like that coordinate is -1, -1. So now we're going to use rise over run. Rise means we're either, and by the way, you want to do this starting from the leftmost dot. Now rise means in order to get from the other dot, do I need to either go down or do I need to go up to get there? Well, we would have to go down. So let's go down 1, 2, 3, and then we would have to run once to the right. So that's 3. We went down 3 over 1. And 3 over 1 is 3. And remember, we went ahead and took care of it at the very beginning. Well, this is a negative slope, so our slope here must be -3. Okay, let's take a look at example B. They have given us 2 sets of ordered pairs. And when it gives you 2 sets of ordered pairs, and it wants you to find the slope, you got to use slope formula, which it provided you at the top of your worksheet. I like to label these when I'm using slope formula: x1, y1, x2, y2. And now we're going to start substituting. We want y2 to be 9 minus our y1, which is 2. And I should have used parentheses there, but I didn't. x2, we want to use 7 minus our x1, which is 4. Let's simplify the numerator first. 9 minus 2 is 7 over 7 minus 4 is 3. Therefore, your answer for B, our slope, is positive 7/3. Example C, it has given us another set of ordered pairs. We are going to have to plug this into slope formula. Let's start with y2 minus y1 over x2, watch this, minus, now I'm going to open a set of parentheses, because notice our x1 is -5. So if I start simplifying the numerator, 4 minus 4 is 0 over 6 minus -5 is now 6 plus 5. And we have 0 over 11. Remember, fractions are division problems. 0 over 11 is the same thing as 0 divided by 11. And 0 divided by 11 is 0. That's our slope for this one. M equals 0. You can have 0 in the numerator. You cannot have 0 in the denominator. Example D. It has given us these two sets of ordered pairs. It wants us to find the slope. So let's start using slope formula. y2 minus y1 over x2 minus open parentheses, because our x1 is negative. If you simplify the numerator, -3 minus 7 is -10. If you distribute the negative throughout the parentheses, that's now +2. And we have -10 over -2 plus 2, which is 0. Now, if you're using a graphing calculator, which you shouldn't be, usually if you don't see me using a graphing calculator, that means you don't need to use a graphing calculator. If you see me using a graphing calculator, then that means you need to use one too. Now, anyway, if you plug this in your graphing calculator, you would get error. The reason why is because, remember, fractions are division problems. -10 divided by 0. Remember hearing you can't divide by 0? Yeah, you can't. Or you cannot have 0 in the denominator. This is undefined. The slope of this line is undefined. On side 2, I'm going to give you some time to just start filling this information in, and then I'll explain it. Okay, this section we did 19 over 1 equals 19. That ends up being 19 degrees per hour. Here for part B, you're going to write time in hours, and then part C, you're going to rent. I don't even know why that word came to mind, but here we are. For part C, you're going to write temp in degrees. I went ahead and labeled each of these columns. This is our X column. This is our Y column. I noticed that the change in X, they're increasing by 1 each and every time. And then this time over here, when X increases by 1, Y is increasing by 19. So what it wanted us to do was it wanted us to use this data and determine the average rate of change. So I did change in Y over change in X. So therefore, we are changing 19 degrees per hour, increasing 19 degrees per hour according to this chart. Which is the independent variable? Your X value, that's going to be your independent variable. And that represents the time in hours. And which is the dependent variable? The dependent variable is going to be your Y. And that represents our temperature in degrees. All right, let's look at this section here and start filling in these blanks. X equals 0. Solve Y. Here, you're going to do Y equals 0. Solve X. For this exercise, what it wants us to do is it wants us to graph the x-intercepts and the y-intercept and then graph them. So we're going to start solving this one. The y-intercept of a graph is where the function crosses the y-axis. It can be found by plugging in 0 for x. So we're going to let x be 0. So rather than 10 times x, do 10 times 0. Now, 10 times 0 is just 0, meaning it's gone, leaving us with y equals -5. That is your y-intercept. And to write that as an ordered pair, it's 0, -5. Let's plot that on the y-axis now. Now over here, the x-intercept of a graph is where the function crosses the x-axis. It can be found by plugging 0 in for y. So that's what we're going to do. This time, instead of y, we want y to be 0. And now we have to do a little bit of solving here. 10x plus 0 is just 10x. Now divide away the 10. And please remember to reduce your fractions if they will reduce. -5/10 is the same thing as -1/2. That's our x-intercept. And as an ordered pair, it's -1/2, 0. Well, -1/2 we'll put right here. It's right in between 0 and -1 on the x-axis. And then we can graph. Just take those two dots and connect them. For example A and B here, well, let me back up a little bit. Note they gave you forms of linear equations: standard form, slope-intercept, and point-slope. You're going to want to memorize those formulas. And then you're also going to want to memorize, given a particular formula, what is it easy to identify? And as we are moving along, I'll make sure and point that out. All right, example A. Here's what it wants us to do. It wants us to write the following equations in slope-intercept form. Well, this is standard form. And even though it didn't ask us this, I'm just going to make you aware of it. If a function is in standard form, it's very easy to identify your x and y intercepts, which is what we did here, remember? These are also in standard form. It really wasn't that hard to identify our x and y intercepts. All right, but that's not really what it wants us to do. It wants us to convert this to slope-intercept form, which is here, y equals mx plus b. First, start by subtracting 3x from both sides. Now 9 and -3x are not like terms, so you cannot combine them. Next, divide everything by 4. That's your answer, although I like the x to go first. You'll usually see it written like that, but both are acceptable. All right, we're about to do example B. It wants us to write the following equation in slope-intercept form. That's y equals mx plus b. The goal here is to get y all by itself. So we're going to have to add 5x and bring it over here. We're going to have to subtract 4 and bring it over here also. If I simplify everything, this is where we currently are. All right, now we have to get rid of that fraction. And if you don't know how to multiply by the reciprocal, or you don't like multiplying fractions with whole numbers, this trick can help. How about we just start multiplying everything by the denominator? So make sure you multiply that by 3. Multiply that -4. Oops, I didn't mean to write -3. Make sure and multiply that -4 by 3 also. Okay, so if we multiply everything by the denominator cancels here, leaving us with 2 times y equals 3 times 5x. And then 3 times -4 is -12. Now to get y by itself, divide everything by 2. The 2's cancel there. 15 over 2x will not reduce, minus, but 12 over 2 will. 12 over 2 reduces to 6, and that's your final answer. And now we are on side 3. Example C. They want you to write the equation of the line in slope-intercept form. Now, it didn't give you these points, but I went ahead and put them there. They have given us a perfect y-intercept and a perfect x-intercept there. They've also given us a perfect x-intercept and a perfect y-intercept there. So we're going to use rise over run. That's going to be way easier. Remember, go from left to right. So in order to get from this dot to this dot, I first have to go down 1, 2, 3, 4, and then right 2. So 4 over 2, that reduces to 2. What am I forgetting though? I'm forgetting the fact that this is a negative slope. See, from left to right, it's going down. So your slope here is -2. Our y-intercept, let's locate the y-intercept next, is right here. That's where our y-intercept is. That's +4. So now we can write the equation of the line. Y equals -2x plus 4. All right, this one here, let's use rise over run. This is a positive slope, so our slope should be positive. Slope y-intercept. Let me go up 1, 2, and write 1, 2, 3. 2 over 3. That's our slope. Our y-intercept is right there, and that's where y is +2. So this equation is y equals 2/3 x plus 2. And then here they want you to graph the equation of this line. You're going to start with the y-intercept. The y-intercept is +2. So from the origin, go up 2 and put a dot. Next, we want to use our slope to plot every other dot. In order to do that, start at the y-intercept. Your slope is -2 over 5. So you're going to go from this y-intercept down 2 and write 1, 2, 3, 4, 5. And put another dot. And I've run out of room. Okay. So I have room over here to put another dot. Here's how you do it. Go to the y-intercept, look at your slope, and now do the opposite of what you should do. This time go up 2 and left 5. 1, 2, 3, 4, 5. And if you did it right, start at this dot, use your slope, and you should run into that dot. So from this dot, I'll go down 2 and write 1, 2, 3, 4, 5. We did it right. And then connect your dots. Example 4, write the equation from form 1, which is here, and 2 in standard form. Standard form is ax plus by equals c. List the values of a, b, and c. So we want to take a look at this. In order to write a function in standard form, your x value and your y value are going to be on the left side of the equal sign. So let's add 2x to both sides. Now 2x and positive y, you can't really combine them. So just write them like this. That's it. This is what standard form looks like. Your x value, your y value, and then just your number. Okay, now for example 5, they want us to take the equation from 2, which is here, and they want us to convert it to standard form. Now, let me go over some rules of standard form. This right here is a perfect example of what standard form should look like. there are no fractions or decimals, and x is positive. It must follow those rules. You cannot have fractions or decimals, and x has to be positive. Well, this has a fraction in it. So in order to eliminate the fraction, what we're going to do is we're going to multiply everything by the denominator. So I'm going to make a note to myself. I have to multiply everything by the denominator. 3 times y is 3y. Here, the 3's cancel, leaving you with 2x. And 3 times 2 is 6. All right, so the other rule of standard form is, well, we need the x over here with the y, remember? So let's subtract that and bring it over here. Okay, we now have x and y on the left side of the equal sign. We have our regular number over here. We don't have any fractions or decimals, but remember, x cannot be negative. So let's divide everything by -1. And now it's in standard form. All right, example 1, write the equation given the following information in the specified form. So we have a slope of -2, and it passes through -4, 6. So we want x to be -4, we want y to be 6. Write the slope, write in slope-intercept form. Well, this is slope-intercept. Here's what we don't know. We know what everything needs to be, but we don't know what the y-intercept is. We have to find that. So we're going to start substituting. Let's let y be 6. M, we want that to be -2. X, let's let that be -4. And then we're solving for b. -2 times -4, +8. And now subtract 8 from both sides. That's our y-intercept. So now we know what the final answer is going to be. We have to have our slope and our y-intercept. Example 2, they have given us a slope of -3/5, and they tell us the line passes through 5 and -7, and they want us to write it in standard form. If they wanted you to write it in standard form, I think it's a little bit easier to plug everything into point slope form. And here's how you do it. Y minus our y1, which is -7, is equal to m, which is -3/5, times x minus our x1, which is 5. Let me start simplifying. Y minus -7, well, that's +7. I'm now going to distribute. That is -3/5x. If you distribute this -3/5 to that -5, the 5's are going to cancel. A negative times a negative is a positive, leaving you with just the numerator, which is 3. All right, let me now subtract 7. Bring that over here. 3 minus 7 is -4. Now it's in slope-intercept form, but it wants it in standard. And one of the rules of standard is you cannot have fractions. So let's multiply everything in this problem by our denominator. 5 times y. Here the 5's cancel, leaving you with -3x. And 5 times -4 is -20. Now, last thing you have to do is you just have to bring this over here. 3x plus 5y equals -20. Now it's in standard form. All right, you're going to like this next one. Example 3, a slope of 3/2, and it has an x-intercept of 4. Well, if the x-intercept is 4, then at that point, y must be 0. So they gave us an ordered pair here, 4, comma 0. And they say write it in point slope form. So let's start substituting. That's my x1, that's my y1. Y minus y1 is equal to m times x minus our x1. Now there's really not a lot to do here. Y minus 0 is just y. Don't distribute that. Just leave it. It wants it in point slope form. That's your final answer. Last one. Y'all are doing great. Passes through these points, and they want us to write the equation of the line in standard form. Well, it gave us 2 points. Let's figure out what the slope is first. We have to use slope formula. Y2 minus y1 over x2 minus x1. Let me simplify the numerator first. Actually simplify the denominator first, but whatever. 1 plus 4 is 5 over negative 6. Okay, so that's our slope. Negative 6. Okay, what I think I'm going to do next is I think I'm going to use point slope from this to ultimately get it to standard form. Remember, that's y minus y1 is equal to, so once again, y minus our y1 is equal to m times x minus our x1. Let me start simplifying. Well, this is now y plus 4. Let me distribute this throughout the parentheses. A negative times a negative is a positive. Now I'm going to do some cross canceling here. Negative 5 over 6 times negative 3 over 1. The 3 goes into itself once. It goes in the 6 2 times. So now we're pretty much doing 5 over 2 times 1 over 1. All right. You know what? I don't like all these fractions that I have going in here. So I'm going to clear the fractions. I'm going to multiply everything in this problem by the common denominator, and our common denominator is 6. Multiply everything by 6. Well, 6 times y, 6y. 6 times 4, 24. Set that equal to, the 6's cancel, leaving you with negative 5x. And if you don't know what to do here, let me show you. 6 divided by 2 is 3, and 3 times 5 is 15. Fractions are gone. Let me combine like terms. Let me subtract 24, bring it over there. Oh, what is that? 9? Negative 9? 15 minus 24, negative 9. Okay, we're ultimately converting this to standard form, right? Yeah, standard form. So last thing we need to do is add 5x and bring it over here. And now you have your final answer. Good job, everybody.